Hello everyone, today we're going to take a look at tolerance chain analysis. So we have a few examples here. So the first example is for we know all these dimensions, x, y, and z, and the question is asking calculate the maximum size and the minimum size and the dimension limits of part A and part B. So calculating the maximum and the minimum size of A and B, also the dimension limits for those two dimensions. So let's take a look. So first of all, for part A, so part A will be the maximum dimension when x and y, they are both in the maximum dimension. So A is going to be the max when x and y, they're the max. So the maximum dimension of A is going to be 2 inches. And the part A is going to be the minimum when x and y are both in the minimum dimension. So the smallest size of A is going to be when x and y are both in the smallest dimension. So this is the smallest size of A, and the dimension limits of part A is going to be from 1.990 up to 2 inches. So this is for part A. And for part B, so it's similar. So the maximum size of B is going to be when x, y, and z are all in their maximum size. So the maximum size of B is going to be 1 plus 1 plus 1, which is when x, y, and z are all in their maximum dimension. And part B is going to be the smallest dimension when x, y, and z are all in the smallest dimension. So the minimum size of B is going to be the minimum x plus the minimum y plus the minimum z. So the answer is going to be 2.985 inch. And this is the maximum and the minimum size of B. And the dimension limits of B is going to be from 2.985 up to 3 inches. Okay, that was the first example. The second example, that was the first example. The second example is similar, but it says, so still calculate the max. That was the first example. Now let's take a look at the second example. So the second example still calculated the maximum and the minimum size and the dimension limits of part A and B. So the difference is it's going to be subtract instead of a plus. So A is going to be y minus x, and B is going to be z minus y. So instead of the previous example, A is going to be y plus x plus y, and B is x plus y plus z. So now it's going to be subtract, so it's going to be a little bit tricky. So let's take a look. So for part A, then the maximum of A is going to be when y is the biggest and x is the smallest, because A is y minus x. So the maximum size of A is going to be when y is the maximum and x is the minimum. So the maximum size of A is 2 minus 0.995, which is 1.005 inch. And the minimum size of A is going to be when y is the smallest and x is the largest. So once again, the minimum size of A is going to be when y is the smallest and x is the largest. So this is the maximum size of A, and the dimension limits of A is going to be from 0.995 up to 1.05 inch. So if you do subtraction, then the calculation is going to be cross. Instead of up minus up and lower minus lower. So it's going to be maximum up and subtract the smallest, and the smallest subtract the max. And a similar thing for part B. So B is going to be the max when Z is the max and Y is the smallest. So the maximum of B is going to be the maximum dimension of Z, which is 3, minus the minimum y, which is 1.995. So this is the number. And a similar thing, the smallest B is going to be when Z is the smallest and the y is the largest, which is 2.995 subtract 2. So this is the smallest size of B, and the dimension limits of B is this range. And let's take a look at example 3. So it says calculate the maximum and the minimum and the dimension limits of part B. So the previous example, you just use one, subtract the other. And this one you're going to subtract twice. So let's look at this example. So part B is going to be the max when Z is the max and Y and X, they are both the minimum. So this is the maximum size of the B. So when Z is the maximum, which is 3, and both X and Y are the minimum, which is 0.995, and this is the maximum size of B. And B is going to be the smallest when Z is the minimum and X and Y, they are the maximum. So the minimum size of a B is going to be when Z is the minimum, which is 2.995. Subtract the max, X and Y, which are both 1, and this is the answer. And the dimension limits of part B is between 0.995 until 1.010 inch. And the next example is it says the basic dimension of A, B, C, D, and E, they are 1 inch of each, and the manufacturing tolerance of each segment is minus 0.03 to plus 0.05 inch. And ask the maximum and the minimum size of G. So first of all, we are going to calculate the basic size of G. So like we said, the basic dimension is 1 inch of each. So the basic dimension of G is going to be 1 plus 1 plus 1 plus 1 plus 1. It's 5 inch. And now we're going to take a look at the tolerance. So once again, the tolerance of each part is from minus 0.03 to positive 0.05. So G is going to be the max when each part is the max. So the maximum part of G is going to be 0.05 plus times 5 of them. So when each one is 0.05, and this is the maximum tolerance of G. And G is going to be the minimum when each part gets to the smallest dimension. So the smallest G is going to be minus 0.03, which is the lower tolerance, and times 5 of this. So the answer is minus 0.15 inch. So the dimension of G is going to be the basic dimension plus the upper tolerance minus the lower tolerance. So the maximum size of G is going to be the basic dimension plus upper tolerance, which is 5.25 inch. And the minimum size of G is going to be 5 plus lower tolerance, which is 5 minus 0.15. This is the minimum size of G. In the last example, it says the basic dimension of ABCD is 1 inch of each, and the basic dimension of G is 5 inch. And if the manufacturing tolerance for ABCD and G, they are all from minus 0.03 up to plus 0.05, and I ask what's the maximum and the minimum size of segment E. First of all, we are going to calculate the basic size of E. The basic size of E is going to be the basic size of G subtract the basic dimension of ABCD, which is 5, subtract 1. So the answer, the basic size of E is going to be 1 inch. And now let's take a look at the tolerance of E. So first is the maximum size of E. So E is going to be the maximum size when G is in the maximum size, and A, B, C, D, they are all in the minimum size because you're going to use G subtract all those dimensions. So once again, the maximum size of E is going to be when G is the max, which is the upper tolerance of G, and subtract the lower tolerance of ABCD. So each one is minus 0.03, and you have 4 of them. So this is the maximum tolerance of E. Now is the minimum tolerance of E. So E is going to be the smallest when G is the smallest, and A, B, C, D are all in the maximum size. So I'm going to use the lower tolerance of G subtract all the upper tolerance of A, B, C, D, which is 0.05 times 4, and this is the number. The dimension of E is going to be the basic dimension. I calculate from here, and plus the upper tolerance, which is here, and the lower tolerance, which is here. And the maximum size of E is going to be the basic dimension plus the upper tolerance, which is 1.17 inch. And the minimum size of E is going to be the basic size subtract, or say the plus the lower dimension, which is 1 minus 0.23, and this is the minimum size of E. And that's all we have for tolerance chance analysis. And thanks for watching. We'll see you next time. Bye.